everybody. I was like, where's the thing? I was closing down things. I was like, where is it? Good to see everyone here. We got Tiffany, we got Anna, we got Snea. We got everyone here. Let's go ahead and take a look. I'm going to make sure MuBot is reset. I got my second cup of coffee. Oh my gosh. Last full week of school. I cannot believe it. We're going to talk about the executive summary and future research here in a second. Snea has a question about 475. Would you want us to simply talk about the transformation and differencing we did and what the data looks like after doing it? I believe so, correct, because it starts out simple. Like the first one, I believe, is just on differencing. The next one's on transforming in differences, then a non-seasonal ARIMA, then a seasonal ARIMA, if I'm remembering everything properly. So just talking about it, what do you see? Plot the data, show the data. And we have a question Anna says, and we'll go look at these in a little bit right here. Anna says, on Ditto, great to see you here. We got MuBot loading up. Anna says, on 320 homework for 1A2, I'm confused on I'm supposed to look at the p-values on the numbers in the first column of the summary. We'll have to take a look at that. I'll have to take a look at what we're building right there and see what we got. Let's go talk about the future research and the summary right here, executive summary. Let's go take a look. So the future research and the executive summary are important parts of your project. And probably the biggest thing we need to know is what do we need to have for those? So let's go ahead and bring up the rubric. So do not, I would say, be short on these. That's the number one area people make mistakes in, is they don't put enough information in these. So when you are doing the project, if you add in a little bit extra, it doesn't hurt. It doesn't hurt to write a few more sentences. And I'm going to kind of point out the key mistakes I see people making when they do not write a full executive summary. Future research is a little more open-ended. Once again, you want to go into new ideas, but let's go take a look on how the graders will be grading you and make this very, very clear right here on what we have. Okay, so the first thing you need to do in the executive summary is lay out what you're doing. Like, who is this for? Who is the report written for? And I would make it very, very clear from the start. This is our company. This is what we do. These are our objectives. So if you're looking at the first part right here, outlines what will be researched. What you're looking at right here is you should have right here, 1, what is your company? What are you researching? What are your objectives? You should be able to make this very, very clear with these paragraphs right here. You should go through, make this as clear as possible. Make sure I got everything closed down that I need to close down right here. We'll close down these. There we go right there. And so make sure to have all this right here. You know, look right here. Minimum details are given, so you're a little short where you could lose points. That someone can know what the project is about and who it is for. So going through these steps right here, making it as clear as possible. What is your company? What are you researching? What are your objectives? You know, like two-ish sentences right here, I would say is good. Maybe you go do a little third just to make sure. You don't need to go crazy, but making sure like our company is this, this, this. We are researching into this, this, this. Our objectives with this research is to figure out this, this, this. So, you know, make it a little bit, what would objectives like, what are you trying to do? What, if you're a tutoring company, like, don't have everyone look at it. What is your goals with this research right here? What are you trying to do? Like, what do you want to achieve with this research? Why are you collecting this data? What are your objectives with this research? Like, what is your goals right there? So make those as clear as possible as you go through. Summary of important results. Now, this is where I usually see people make a mistake. It says too many results. Please tell me if the grader, you don't want to just literally copy paste. I really think this one right here is when people just copy paste all their results. And I wrote this rubric a while ago, but like if you're just taking all your results and copy pasting them up to your executive summary, that's not really summarizing them. You want to take your report and condense it down. Like the executive summary is a condensed version of your report. So you really want to just take what you have and start condensing it down here. So we have our first thing right here in our executive summary. What is going on right there? So our first thing, really? Now do it. There we go. Let's put the full executive summary up here at the top and make this very clear right here. It's almost we got like subcategories. The executive summary right here, we want to outline what is being researched, who it is for, what's our company, and now we need to go to the results. Now, where I see the mistakes right here, let's put this. Condense down your results. Condense them down. Bring them down to a smaller version of what you're doing. You don't want to mention every result, but you want to mention like key results. Next thing, give numeric backing. I literally, when I'm grading these, if I look and someone did not cite numbers, like said, this was found to be statistically significant with a very low p-value of this, like we have strong evidence for this, give some values, give some numeric values, maybe the most important ones. Like there was a difference between males and females found of this. There was a difference between freshmen and sophomores found of this. Give important numeric backing that could help us make decisions. So that's going to go down to the last part here in a second. But I think the biggest thing I see people doing is they don't really condense their results down. They just start copy pasting and they have a paragraph down here and they just say, I'm going to use this sentence from this. When you have a paragraph, think, how can I take this paragraph and turn it into like the two most important ideas from this paragraph? The executive summary, while we do want it to be a little bit longer, like don't go too short on it, you want to think about how can I optimize what I'm saying to be as efficient as possible, like condensing down everything into shorter versions, but you still want to give that numeric backing. So I see that big error where I don't see students giving the numbers. The action items. This is where a lot of people lose points too, is the action item needs to be clear and also connected to the report. So whatever you're collecting data on here, whatever you're finding, so let's go here to action items. Let's grab this little portion right here. So probably the biggest errors I see when people are writing their action items, we'll do this, copy format. Oh, really? Thought that worked. There we go. And so the biggest error I see when people are doing this is they are not giving a very clear action item. What will your company do from the data above? Be direct. Connect it to the research you just explained. Basically reiterating right there, but when you look at this right here, this is pretty much, does this make sense here, Tiffany? Like if you look through how you'll be graded on each of these criterion right here, you have an executive summary, which is going to outline what is being researched. This is the very start of it right here. Then you're going to summarize important results throughout it. So make sure your results. And then the last part here, which in truth, I would probably do the following. This would be 2 sentences. You could get it done in 2 very strong sentences. I'm not talking like my company is Brian Stevens Incorporated. We're studying tutoring. Maybe you need to go into a little more detail than sentences that short. Probably here, I would say 4 through 5 sentences. And then here I'd do another 2. So maybe about 8 sentences, 8 strong sentences. If you go a little bit more on these, not too bad. That's awesome right there, Tiffany. Great stuff. And so this is a really good example of what we should be seeing. And if you ever think you're graded too harshly, just let me know. But this is a good kind of walkthrough of what we want with the executive summary and how to get the points. Once again, make sure to be looking at the rubric. And if you ever disagree with how you're graded, like I thought it says like right here, I lost credit. I got partial credit. Action item is given, but could be elaborated on further. Ooh, so that if you just say, we're going to help students. Well, you was it connected to your report? Is your report on like making a donut company and you're going to help students? Well, then that action item is really not connected to the report. If you didn't even talk about like what your company will be doing, then you have no action item. So pretty clear grading key right here on how you will be given points or lose points based on your executive summary. Let's put a pause in the video right here. Here, we'll do this. When I put tags in the video later, it helps me see this right here. Little coffee, little relaxing. We'll talk about the future research here, and then we'll do Sneha's and Anna's questions. Great job. And then we're open questions. If you're watching right now, drop a question in the chat. I'm just going to drink all the coffee. No more coffee for anybody but me. All the coffee. Somewhere along my life, I got addicted to coffee. Maybe you did too. So it's kind of true. Coffee is a drug. It is a drug. So let's hop here to the future research. Here we go. Okay, so now with the future research, how will you ace the future research? And so I think it happens to all of us. I think it does happen, Hannah, right? Somewhere along the line, it all happens to all of us. We all get addicted to coffee. Future research examines new ideas. Can you see the capitalization right here? Yeah. We can take a look at that. That's some, I think, the seasonal ARIMA, right? So examines new ideas that go beyond the report. New ideas that go beyond the report. So future research is clear and also connected to the report. So you don't want to say like, oh, we're a tutoring company and now we're going to open a spaceship company. Like, no. You need to like connect it. Like, you're going to be expanding your efforts here. You're going to be looking into this. This is what we're going to be doing. Future research is given but could be elaborated on. So this is where you're pretty short, and your future research is like 2 or 3 sentences. Future research is given but not well connected to the results. Once again, this is where you're saying we're a tutoring company and we're going to open a spaceship company, and here's where you just don't do it. So that's how the graders will be grading you right there. So really, what are you trying to do? Well, let's go grab this right here and talk about that future research. So we're just going to change our document right here to say future research and talk about the goal of this. How I would kind of do it. Kind of setting out a structure for doing it. Boom. And there we go. Okay, so that's what we must do right here. So one, we need to go off a bold right here. So the first thing we're going to have to do is come up with new ideas. So like new variables to collect on. New areas to explore, like maybe we're venturing into online tutoring or something like that. Just like what have we not thought of? So what have we not thought of yet? So that's what you're asking, is like you're coming with new ideas that you haven't thought of. So it'd be like, we could explore this, we could examine this, we could go into this idea, we could examine this. We need to collect data here. We expect this project to take this long. We're asking it. Maybe even make an ask. Let me put that right here. I don't think that's a bad idea. Give an ask for the new future research, or give a proposal to the company. So many people are going to do this now. Outlining what you want to do. Outlining what you want to do. So, you know, giving a proposal being like, we want to do this right here. We want to expand upon this idea, and we're asking that the company put forth this amount of resources, and here's the timeline. Maybe give a timeline. For the new research. So maybe give a timeline for the new research. These are just ideas right here, but you're just going beyond the report. Like, these are things not covered in the report. Like, I can't point this out enough, that when you're doing future research, you're talking about this like to be continued of your report, where there's so many ways you can go. This is so open-ended right here with future research. The last thing you want to do is to start just going through the results in your report again. Like, the last thing. Let me put this right here in red. Do not start going through results. No, I could do it. I could just hit caps lock in the report. Again, I was holding shift right there. Do not just start going through the results in the report again. Don't just being like, oh, you know, we found this for this data. We found this for this data. You want to connect it a little bit. You want to connect it to your report to be like, you know, we're studying students. So let's say right here, connect, oh my gosh, connect the ideas in future research to your report. So you want to connect it. You want it to be like, we have been looking into this. We have been studying this. We want to examine this further. We really want to, you know, delve more into this by collecting data here. Here's our ideas for the future, and here's what we have for a timeline proposal. We will continue exploring this, you know, blah, 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 blah. It's almost like, if you've read scientific articles, it's almost like a discussion or something, to where you talk about like the limitations. This is our limit. I think it's the limitation section. Maybe that's held in discussion. But when you talk about like, here's our critique of what we're doing, or here's where, you know, we could do better. It's that idea of like, you know, it's basically the brainstorming session of your report. This is the company saying like, well, where do we go from here? And I will say this is something companies really value, is they value innovation. They value people who are going to take the initiative. And this is your chance right here to be like, I got some ideas. And that's something we try to train with our students, is to be like, come up with some ideas, present some ideas, take that initiative, and walk forward and say, hey, we should maybe look into this. Maybe we should be doing this. Because a lot of these ideas you see from companies, whether it be Post-it notes from 3M or just any sort of invention at a company, is just somebody saying, hey, you know, we could do this right here. I have this idea. Hey, I made this little sticky note thing that you can put and you can post on your wall so you can remember something. And someone's like, hey, that's a really good idea. We should start making those. You're like, oh, yeah, maybe we should. So this is your chance right here to propose your ideas, to go forward, to kind of set the path. So the future research needs to be new ideas, things we haven't considered that are not included in this report. So that's the future research. Let's head back over to the main screen. Is it making more sense, Tiffany? Like, I like the graders to be a little bit nice on those. I don't want them to be too mean. Not that I ever want them to be too mean. I'm going to load in here a new song. You know what I'm going to do? I'm loading a new song while we're doing this. Now we're going to get a new song loaded up. Let me grab this new song right here. At the end of Statue 1 yesterday, we found a whole bunch of new music. Oh my gosh. Okay. Here's the new song of the day. This song is awesome. Needs to be raised. We like Wend. How many cents do you recommend for future research? I'd say like 5. This song's crazy. We went through the YouTube library and we're like looking. I'm going to get some 474 loaded up. Because we're like, we need some new music. Fade. Oh no! Sorry, I hit the button. Now it's ready to go. So I think I got the STL decomp model already created. We just need to filter 1 series correct. So that'll give everyone a unique thing right there. Everyone should have some unique models. Got some spacey music going on right here. Getting new things set up as in the background as we do this. Let's go grab that 474 data and talk about it here a little bit. I think you're talking about the seasonal model, right? I really like the electronic sound of this music. The grader will start working on the new stuff here soon. I think you're going to really like class today, Snea. I've got something really fun planned. Number 4 on the seasonal. Let's go take a look at that. And then we are differencing and transforming to use the same filter data. I believe so. Let me take a look at it right here. Let's go take a look at the new ARIMA homework for 474. How many sentences do you reckon? Oh, we already answered that right there. And I think we got it. Let's go take a look at the 474 student skills data. Nice job, Snea. Already completed most of the work. Great job. Here we go to the main screen. Here we are with some 475. I think I was saying 474. I was listening to that song. It's pretty crazy right there. Okay, here we are with the seasonal ARIMA. We've got the, we need to choose a series from the U.S. employment, the total employment in different industries in the U.S., United States. So don't take mine right here. I'm not going to do the full thing. Produce an STL decomposition of the data and describe the trend and the seasonality right here. So let's go ahead and take our U.S. employment. And, oh, we don't have some FPP3 loaded up. Now we've got FPP3 loaded up. I've got lots of projects I need to manage my time. Well, no, that's great right there. Great work right there. So, and ooh, Snea, you noticed, did you notice what's up with this right here? I think you should notice this. We talk about this a lot in class. It's obvious with this, it's obvious with this, it's obvious with this. That's the first question right there, pulling up the graphic in the background. But that's some obvious stuff going on right here. That's very, very obvious. Okay. Let's go right here and take a look. We've got the different series right here. We won't use the first one, but let's go here to levels of series ID, null. Oh, we can't just look at that? Series ID. There we go. Let's go to unique. And there's the unique pay NSA. Pay NSA. I don't even know what that is. I'm going to go here to the following. Looks like, well, but I know what you're seeing, but I know what you're seeing, but this is this right here, Snea, and this right here is a big issue. I know you're seeing this right here. I know you're seeing the PACF on 1 and AP, so I know you're seeing this, but this right here is so close to 1, and you're seeing this right here. and you're seeing this right here, there's a major issue with this data. Like that it indicates something huge that we need to do immediately to this data. Like that's like, oh, that data is not stationary. So we need to do something to it. I think you get all my hints right there with that. Like, oh, that data is not stationary. We need to take those differences. So that's got some major issues right there. Like if you see that with your data, you have to be like, ooh, something going on right there. Filter, dply r, filter, and we want to go to series. I've already got this copy paste. Equals this. Series ID should work. Error. There we go. Quotes. Oh yeah. It might be after we do the steps to it. Let's go ahead and take this. And let's say sub. So there's our sub right there. We're creating a subset. Call it subset whatever you want. Subset, cool. And let's auto plot this subset. So let's go to subset and auto plot. And the y variable of interest is... Ooh, oh, really? Oh. Wait, right here. Let's go to subset. A lot of NAs. That's not good. There we go. Okay, so we should get it. We got a lot of NAs for a lot of the periods of time right there. So what was the name of that variable again? Employed. And wow. Don't love it. Ooh. And I think this was like coal mining or something. So this is U.S. employment. And we're looking at mining, logging. Yeah, so what has been happening to the mining and logging industry? You know what we're going to do? We're going to pass this through a ggplotly. I think someone found a way to get the ggplotly to go in. What do you notice about the trend in this data right here? What do you notice about it? There is a trend in the data. There is a very strong trend in this data. What is going on with this data right here? And there's also some seasonality, it looks like. So yeah, this is monthly data right here. And this is real data. We're looking at U.S. mining employment, forestry and mining employment. It might be jobs in the thousands, I believe, or so. Yeah, there's and this probably, if we run a ggplot on or an ACF, PACF on this, there is a trend. So there's some sort of slightly linear, maybe a little bit non-linear trend. There's a huge portion of seasonality in here. Like there's major seasonality, huge dip in that season. Whatever happened here at the start of the year. So is the start of the year the lowest? Yeah. So really during the cold months, you see a decline in the employment. But overall, negative trend going in here into the 2000s. Kind of leveling out. And it's pretty, his data is pretty up to date. One of them, he even has some data from the most recent showing what happened with COVID for some of these. Pretty cool stuff. You have to download that data from the site to get it though. I was looking over that when I was looking over these plots when I was first running through all this. So we see a negative trend. Now we need to decomp this though. So we should be able to decomp it pretty easily. Let's go here and I'm going to grab the code. The STL decomp is so nice with the code he wrote. So let me go grab that FPP3 code. And we're going to go over here. What? Oh, I did FFP. I can't even speak today. FPP3. And time series decomp. Let's go here to the time series decomp. And let's go to the STL decomp. And right here. There we go. Got the STL decomp. Drop it in, and it's just using the model right there with the trend window, how much we're going to smooth this out. And we've got different variables in here. We're using not U.S. retail employment. We want to go to our subset. On our subset, we're grabbing the employed, same sort of thing right here. The trend window going to be the same, seasonal periodic, robust equals true for outliers. We can get the components, and we can auto plot those components. Let's go ahead and do it. Oh, missing values. Does not support series with missing values. So what we should be able to do right here, since we have missing values, is we might be able to bring this down to complete cases. Let me try this. Let me go to my subset. And let's go here to complete cases of the subset. And let's go only to complete case rows. There we go. Let's overwrite our subset with just complete cases, and there we go. Fixed. So just because the data was collected this way, it looks like they weren't collecting it for those times. So I could definitely see that being a stumbling block right here. Does that make sense, Snea? What I did right there is I had a series that had missing values, and I think other people are running into these issues with some of their data. But this code right here looks to see if it is a complete case. And if it is a complete case, it returns true. What does complete case mean? Complete case, and I think we have the original subset right here. Great job. This is not a, why would this row right here, why would row 2 not be a complete case? Like if I run complete cases on subset, on sub, which was our original thing, and we look at row 2, and we should be able to just run 1 through 20, let's run. If you look at these first right here, they're not complete cases. Why are these not complete cases? I mean, what does a complete case mean? There's NAs, exactly. So it's looking at the rows right here, and it's saying this is not a complete case. If you go down here to eventually we get to some complete cases, the first complete case will be on row 613. So if we run this right here, and we go to row 613, the last one will be a complete case. So when you're seeing this true right here, it's not because there's a value there, but because it's a complete case. So what I did is I said only take the rows from subset that are complete cases. I did overwrite my subset, so watch out. It can be a little bit of a, you're overwriting your stuff, but this would work right here. It would store everything and get everything good. So we're good to go. We got what we want. Now if I ggplot this, you know what we could do? Now if I ggplot this, instead of getting the original plot where I had to zoom in, we're going to get the plot right here with everything we want. And I do want to give a shout out once again to the following. The amazing library ggEasy. ggEasy makes life so much easier to where I think we could just take and store this into object P. And that's stored in object P. And then we can go to P plus ggEasy title. We loaded ggEasy, right? Oh, I didn't load it. ggEasy title. Oh, there it's easy. That's what it's called. Easy title. Easy center title. Oh, so we need to go plus. You don't run anything on that. So you go to plus gg title. And you say mining jobs. And then, oh, we didn't add the plus. Oh no. I think maybe we need to throw this on right there. Can't tell I love graphics stuff. There we go. And then we throw on the center title on this. So let's move this down to this line. Move this over to here. And do the GG or easy center title right there. And we took our ggplot and moved it over here. Okay. So now we get a nice and neat plot. And this is kind of the goal right here, especially when you're turning in stuff. Try to make nice and neat plots and think about how you can do this with your code and kind of build and append your code with doing it. So I do like the way this looks mostly. We'll make it look like that so you can see everything going on right there. And now we have our STL decomp. Our STL decomp of this data, we did kind of see it. The seasonality, and what's the biggest component right here, Snea? Good question right here. Good question for the final. Pretty quick and easy question. What is the biggest component of this data right now? Which kind of points to, we'll definitely need some of this. What is the biggest component of this data right now? What is the biggest component of this data? The biggest component of this data would be the what? What is the biggest component of this data? We saw this originally when we looked at it. We could do some seasonality plots and stuff too, but yep, the trend, exactly. The trend is the biggest component of the data right here. You might say, well, isn't that the smallest? Remember, this is like a zoom out, so you'd have to zoom in. You can also see the scale right here is larger. So this right here is the biggest component. Review these portions where we talk about the STL decomp to understand that the biggest component of this data is the trend. Seasonal is a very smooth pattern right here. So we're seeing a very consistent seasonal pattern, which we originally saw in the original data. There's our plot right here. I wish we had the zoom in. I think it's on the viewer. So you can see a good seasonal, but you can also see right here the decomp. Nice that we can switch between these. So there's the seasonal pattern. The trend is going through here, and the trend is the biggest component of the data right there. So the trend that we see, a little inconsistent. So yeah, looking good. Let's go back and look at the question. There we go. And describe the trend and seasonality. Well, yeah, so we've done that right there. Don't use the one I'm using. Don't use the same series I'm using. So we just need to talk about that. Do the data need transforming? If so, find a suitable transformation. Yeah, it's definitely not stationary. So the trend is causing a non-stationarity to it. Does my data need transforming? And I need to look at, let me go to the viewer. Why would I transform this SNA? So there's two, and I'll mention the two reasons. And there's one of these reasons. So why would we transform this? And we're going to look at the, its features, Guerrera. I got to like memorize these codes better, but I know it's the features Guerrera. And I swear my search doesn't work on the book anymore. I don't know if he made any change to it, but I can't do the search on the book. But we want to do the features Guerrera. Trend, yeah. So we don't really see heteroscedastic. So I don't really see a changing in strength of this, which could be a multiplicative series. It looks pretty consistent in strength of spread of the data. So this is stat 1 plot is really not thickening. And then square root worked pretty good on yours. Might, yeah. And a lot of those can be done via the box Cox, because the box Cox is a family of transformations that can cover a lot of these. So I usually just go with box Cox. Better than the box Cox? Oh man, 100 points right there. So yeah, give it a shot. And so I'll take a look at mine right here. Another reason, as Snea points out right here, we could transform to fix trend to create a linear trend, and then also fix unequal spread, which is heteroscedastic. So do we need a transformation here? I'd say due to the trend. My biggest concern right here is the trend in the data is nonlinear. So I'd say, yeah, I'm gonna start changing around that trend. So let me go right here, and I guess I could just try like an SQRT on it, right? So let's go here and just run SQRT. We should be able to run on this, right? Right. Let's go here. I think that changed it, right? Not really helping it. Not really helping it. Let me try the box Cox on it. Let me try it. Let me go grab my Guerrera code right here. I want to know what's called Guerrera. And so time series, let's go here to the box Cox transformation. Where is the transformation? Here it is. I think it's going to be down here. I always forget where the transformation's at in here. Transforming, where are you at? Other features, ACS, simple statistics, times for toolbox, times for workflows, fit values, using transformations. Here we go. There's box Cox. Here we go. So, and where's the features Guerrera? Wait, what? The search function, he took away my search unless... See, look at this, Snea. It doesn't like search anymore for me. He said, you have searched my book too many times. And that, like, I swear the search function doesn't work. I don't know what happened to that. Let's see right here. Let's find transforming and adjusting. There it is. I'll start square root inside of the box Cox and still find the square root is better. Might be. It might be. Very well could. Here we go. We got the transformation. Where's the feature at? No. Feature, Guerrera, 1993 is when the person made it. Here it is right here with the lambda. So there's his transformed on that. So he really didn't make a much better series with that. Like, yeah, I don't think you're really doing it. And then he plots it right here. Adds a cool title to it. So let's go grab it. And let me see how my box Cox is doing. So we're not using the OS production. We're using our subset. We're doing the employed right here. And so there's our subset, features, pulled lambda. Value of lambda we're going to be using right here is that. Ooh, that's a pretty strong lambda if you ask me. Now we're going to go to our auto plot, and we're going to auto plot everything we have from the, he's running his data right there, the box Cox, running it on the employed, and we don't need all these labels. I think that's just all his label with some LaTeX code right there. Yeah, he's pulling LaTeX. I don't even do that code right there. Okay, here we go. I'm thinking, what do you think about this? The box cocks really didn't help this out right here. What do you think on this? Because if you look at my subset with my original data, like let's go through here and look at this because I am not too happy about this. Here's the transformation. Here is the original. Ooh, wow. Yeah, this is a messy one. Original, transformed. Yeah. Yeah, I know this is, we're not getting anything back on this. SQRT. Nope. Log. Log base E. I'm seeing nothing here. This is, yeah, we're really seeing nothing. And what'd be really nice right here is we could probably, you could do like a facet grid. So if you store each one of these into like G1, I'd probably add titles to them too if I go back and do this. But so I think I don't use facet grid nearly enough. Let me go grab a facet grid right here. So facet grid example, good. Someone's making a facet grid right here. No, that's not what we want to do. Put 4 plots in 1 plot in R. We can do it right here with the param flow, but combining plots. So someone's showing an example right here that looks what I want to do. So let me check that out. Plot. They're just doing the param flow. Will that change it? Okay. So let's put the param flow right here. And we should be able to, could I run G1, G2, G3, G4? And let's run this right here and run it. And do we get it? Nothing. Really. Why's my param flow not doing it? These are, oh, it's the auto plot. Okay, wait. Combine multiple ggplots in R. Here we go. There's a way to do it really quickly. We'll find this out really quick right here. Okay, someone's got it. ggArrange. It's ggArrange. Okay, nice and neat. Really, that's all it is? ggArrange. So we're using ggplots. We can't use the param flow trick. So ggArrange. Do I have ggArrange? I don't. What is ggArrange from? ggpubr. I have ggpubr. And so ggArrange looks to be in ggpubr. And we'll set the theme right here like they did. And so now we're using G1, G2, G3, and G4. And we'll put here a C and a D. We'll label these more in a second. There we go. How's it looking? There's my figure. And here we are right here. So this, Sneh, I would say this is one of the best things to do. If you're talking about presenting data right here, I would start doing stuff like this. Does this make sense here, Sneh? Like, these are all the auto plots compared to each other, which really exemplify that we're not getting any return. And someone could see right here the differences in the figures. We might not even include A, B, C, D. We might just leave these blank right here for the labels. And then we would just get the following is gonna, yeah, we just need to remake it. But now we get the graphics right here. And that's really a good way to combine plots together. You can see the original. It's pretty easy to tell what transformations are being done right here to them. Here's the original data with the employed. Here's the box Cox. None of this is helping with the trend. I'm not really seeing differences in the seasonality much. Like the heteroscedastic nature doesn't exist much. I mean, maybe it's a little sharper in some areas, more declines, but we're not fixing this. These transformations are not improving this. So I would start, and this is the biggest thing I like to say, and this kind of goes into what I suggest to everyone, is to always be thinking about new ideas you can do with this. Like, how can we make this look nicer? What could we do to all this? We could probably add like a title to this, plus GG title. Let's say model comparison or transformation comparison. And then we'll add on to here a last thing we like to do this is go here and go plus easy, and we did this earlier, center title. And there we go. And if it hopefully, we might take a screenshot if it doesn't copy paste nice and neat. But here's the transformation comparison right here, and nothing turns out well. So Snare, I would highly suggest doing things like this because we can really make some really great graphics nice and quickly inside of R. And yeah, we're seeing nothing. I mean, that's what this communicates. None of the transformations are achieving any of my goals with this data. Maybe you achieve something with your transformations, but mine are not. Mine do not show us any sort of return on, well, we had no heteroscedastic issues, but we're not fixing any of the linearity issues right here. So sometimes you win, sometimes you lose, and this one we did not get any returns on it. Are your data stationary? What do you think, Snea? I'll let Snea answer this one right here. Yours looks better? Yeah, and I would show this right here. I would use the similar code. I would try to do things like GG arrange. Like, that's just so nice. That code is so nice right there. I'll have to remember that. So I find a lot of great codes, and then I forget, like, you've just got, like, GG arrange, which arranges your GG plots. This is sarcasm, right? Good morning. Good to see you here, Kayla. Send me on Discord, Kayla, and I'll send you all their assignments. Of course, of course. Kayla, here's what threw me. Yeah. Oh, Kayla, that's so awesome. Here's what threw me for a loop, Kayla, is what he's done. And so I'm honored, Kayla, that you're swinging by learning new things. So we've got here all the notes for instructors right here. Such a great thing for a resource. But he actually changed everything to use totally different methods right here in his FPP3. FPP3 completely changes everything we make right now. Kayla, is now a TISBL. So everything we make and use is a TISBL. We no longer use the time series object. So I had to like reorient my brain. So literally you go through first and you make a TISBL, and everything is then through the GG or the dplyr universe. So this caused a little reorientation in my brain because I'm used to doing different codes, but it really helps because everything now is... so if you go from FPP2 to FPP3, he totally changed his whole methodology. So yeah, I also learned why the package is called Fable, because the package Fable is kind of a story that someone would tell about the future, or like, but it might have some truth in it. But, you know, like fables have an element of truth, but are not completely true. So that's why he calls it Fable, because it's like time series forecasting, because it's like a story about the future. I watched a presentation he gave on it, and I was like, oh, that's why it's called Fable. That's why he decided to call the package Fable. Anyways, are the data stationary? Snea, I think, is joking. I'll go with no. Yeah, I'd go with no, too. These are not stationary data. So it's really cool right here. Check out the new way we do this right here. We're actually, I'll try to do this from memory. Pull a little memory right here. Let's try it. So what we're going to do is we're going to try to do this from memory. We're going to take our data right here, and we're going to pipe this in. Here's our data. We're going to pipe it in. Then we're going to call the model. And the model right here is in Fable Tools. And so now we're going to pull an ARIMA model. I think it's capital model. I'm going to double check right here. So let's go over here. See, I'm going to cheat. I'm going to go down here to my cheating, to my seasonal ARIMA. And you can see right here, where's the model? There's some differencing. Notice just model. Okay, I got a little bit worried right there. You're joking. So there's the model, and we're going to call the ARIMA right here. So there's our ARIMA we're calling right here. We can name the model. So let's call this first model. Let's call it M1. M1 equals ARIMA. Put in quotes right there. M1 equals ARIMA, name of the model. And now inside of this model right here, we need to put what we're predicting, which we are predicting the employed. And so we're going to write right here the employed tilde, and this is where we do the PDQ. So now we're going to do the PDQ. So we create the ARIMA with the differencing data or without. So the differencing can be done inside the ARIMA. Which of these is the differencing right here? And let me try this because this is going to be important. Where is the differencing? So where is the differencing here? And so this, Kayla, this is completely different right here if you're looking at this structure right here, because you can notice the PDQ right here for the ARIMA. So where is the differencing? The I, yes, you are totally right. The autoregressive integrated moving average. No, you're right. No, it is the I. The differencing is the I 100%. And then where is it over here? No, like you mentioned the ARIMA, which it's the I in the ARIMA. And then where's it over on the other side of this? So where is it over here? And we could try, it's definitely got some, I'm just saying, it's definitely got some. Let me try the following. Everything should work. Everything's fine. There we go. And then we're going to pipe this through. Check this out real quick. Let's just pipe this through some accuracy. And there we go. There you go right there. There's everything. So we just piped it through right there. Let me see if I can take this. We'll put the model like that. And then we'll pipe our accuracy here over at the end. And then let's go here to where our models are at. And let's go and take the model here. Put a, oh, we forgot a comma. And this is just how we build code. So now we're going to make 5 models. Let's try. So what did I do right here, Snea? What did I put into my model? So just right now, my first model, which is all my models, but we'll change these up in a moment right here because we should just get, like the only models right here are looking at a what right now, which the RMSE right now is 9.67. That's the typical miss the model makes. 320, if you're listening, RMSE, typical miss the model makes. So my model is only including what sort of information right now? What is my model only including right here? What is my model only talking about right now? My model has only included this, which this is a very fair test question. You should look at this code right here and understand this model is only using what's right now. I'll pause. Correct. Basically, ditto expand further. It's only taking into account what? You are correct. Just expand upon that idea. It is using some sort of differencing, which is the I, the integrated. And it's more importantly using what? Which we did pick up some components of this. We're talking about these components right here. So this one specifically right here represents what? So it's in the capital PDQ, which those are the whats. The capital PDQs are for the what components of the ARIMA. Kayla there got 100 points. Yes. Kayla is 100% correct that is the seasonal differencing. We're only taking into account the seasonal differencing. Oh, no, that's all right. This is the seasonal differencing right here. So let's try a model with just regular differencing and seasonal differencing. Let's try a model with regular differencing. We're just doing a little looking around. Let's try an AR11 with seasonal, and let's see what we get. We're just doing a little looking around right here to see what we get. So, and then we're gonna do some. Okay, so here we go. Ooh, something picked up on something. What do you notice right here? And we're starting to see, especially down here. Let me expand the table. We're starting to see something. And the RMSE standard deviation is about 0.2. So yeah, that eliminates that. What are you starting to see right here, which is where we're like, okay, now we're starting to get into a realm of we've got something going on right here. Do you think we need the differencing right here? Because now I might try something more. Well, we could compare AICs. Why are we not getting AICs? It didn't give us the AICs on these. Got the ACFs right there. It didn't give us AICs. We can compare the RMSEs. Yeah, we could. Why is it not giving AIC? So doing a 1 or 0 on each slot changes the ARIMA the model is. Well, then we have to know what each one of these are right here. We have to know what the P, D, and Q are. The P is the autoregressive, the D is the integrated, and the Q is the moving average. And then the capital PDQ are the seasonal components of the autoregressive integrated moving average, integrated being differencing. Report. Oh, thank you so much, Snea, right there. Boom. There we go. Snea says, let's look at those AICs. So which of these is on the best track right here, Snea? So, and I love it. It's okay if you're seeing this right here. That's what's so cool about all this. What we've been doing now with the piping of it, like Kayla will tell you, this is very different from what we were doing over the summer. So I was reading up over the book, and right there, Snea knew the code. Snea said, just use report. So we just changed it to report, and There we go. Now we got the report. So what are we looking at right here? Yeah. Exactly. This is really great. And Kayla, if you didn't know it, Kayla got an internship straight with what we taught in time series. And now we're going even more advanced. Like, I'm always trying to improve what we're doing in the time series course to the most relevant. That's why we don't, like, sorry, Kayla. Glance might show the AIC, so we can do a glance right here. There we go right there. Yeah, the glance is showing it too. Glance is another dplyr function right there. And then there's, was it broom or I think of another one. But the glance also shows it too for this table. Looks like model 5 is winning out right here. And these are pretty big AIC differences. Remember, lower AIC is better. We could compare RMSEs, but AIC is good and AICC is good. Both of those are fine metrics. It's a pretty clear choice that model 5 is the best. Let's use the idea of model 5. We'll put model 5 as model 1 right now. We're kind of doing our own search. Then I'm going to do the auto ARIMA to finish this off right here. So let me copy paste model 1 as kind of our search. We're kind of doing our own search grid right now. And then we will do the search and see if we beat the search. Can we beat the search? That's the question. Let's increase the differencing right here. So we're using that as our main metric right here. Changing the AR component also made a slightly bigger difference. Oh yeah, did we change the AR? So we haven't messed with the MA yet, which is using the errors. So let's bring the MA in. Let's do some double differencing. Try double differencing on one of the components. And let's try increasing the AR. Okay, kind of doing a little search grid around it right here. Oh my gosh. Oh, it said, no, you can't. Probably we had something with the unit circles right there. We couldn't do it. Ooh, but look at this return right here. Model 3 and 4 could not be estimated. So models 3 and 4 were a no-go due to kind of some parameter constraints on it. Having more than one seasonal difference is not recommended. Please consider using only one seasonal difference. Love it. But if you look at the AIC, our best AIC right now is on model 2. So model 2 is winning out with 1432, and that's winning out. So model 2 is kind of our metric now. It said no. So let's use model 2 as a metric to go by. We're going to see if we can beat everything. It really doesn't like that multi-differencing. It says, no, you can't. I don't want you doing that. It said no, and we said okay. Model 2 is kind of our metric to go by now. Let's put it at the first model. Model 2 is now model 1. Let's try increasing our metrics over here. And let's see what we get. Model 2 being our metric to go by. Rectangle a little wrong. Change 3 of the more numbers. We're kind of reaching an impasse right now. So an AIC difference of 2. I'm going to go back to looking at the RMSEs with the accuracy. So I'm just going to see how my RMSEs are doing. Model 2 looks to be the best choice. And RMSE is indicating model 2. So and look, we went from like an RMSE of like 2.2 to start to an RMSE of 1.82. So it looks like we're here. Let's go ahead and take our model, and this is going to be our model choice. I'm going to retake the code right here, and I don't want to destroy all this beautiful code we've written. We should be able to pipe this through. So model 2 is going to become our choice model. That is my best. Working with this data a little bit here, that's the best we got going. So let's say my model. And there's my model. Good stuff. Let's pipe this through into GG. It's... Why can my brain not think of it? GGTS plot. TGTS residuals, right? Well, how we looking? And there's a way to get the partials on here, Kayla, pretty quickly. Kayla, yes. There's a way to get the partials. Oof. What about BIC? we don't do BIC here. Unless we win by choosing our model. I think we're looking pretty good. And I think we can do partial equals true on the on this to get the is it partial? Let me go to the GG time series residual. There's an argument, which Kayla and I looked over this for a good bit. Oh, GGTS display. I think I want that one. Oh, no. It's mad about that. It said, nope. It will run this. Okay, good. And let me look at that help function again real quick. And type equals response. There's a way to get the partial. I see it in the book. Oh, we'll worry about that later. Here we go. Overall, what do you think? Oh, no worries, Ditto. About the ones in repeat the question again. I repeat the question. I'll make sure we answer it. Snea, what are your thoughts on this? Because really, I see like one issue with this, and it goes back to 201. And there's really just one issue I'd say with this. Like, I mean, it's just like, I mean, so this should be a pretty big, unless you beat Rob. Let's take a look at his algorithm next here. We'll do that. We'll run that, and then we'll do some 320. So because we kind of just did part D right here, identifying useful ARIMA models. What do you think is like going on here with this? And yeah, we got that crazy point. We got this extreme point. But overall, like, if I'm thinking about forecasting forward with this, forecasting so many periods forward. Oh, you understand? Oh, yeah. That's why I didn't see it. The model has become pretty good. This region in here, I'm a little bit unhappy with. Those residuals look to have some sort of iffy sort of stuff. No worries, Snag. Great job. I want to see if we beat the auto ARIMA, because we always want to beat the auto ARIMA. So let's go grab the auto ARIMA right here. Oh, there it is right there. There's lag 36. And he did make an auto. So we're going to grab an auto ARIMA right here. Here's the auto. And let's throw that on here to see if we beat it. Because that's always our goal, to beat Rob at his own game. And so let's take this right here, grab the auto ARIMA. Here's the residuals for the auto ARIMA. Ooh, I should have distort it. And then let's run the accuracy on it. So there's the accuracy. It's taking a moment right here. But we're going to take out some 320 here in a second. So we'll see how this works. Oh, I should have stored it. We have to run it again here in a second. We'll talk over. So this is why you might not run the auto ARIMA. It's going to take a moment. I guess we had to search for a moment. We'll chill music on right here. Oh, yeah, because you stored your residuals into X, right? And so what we do is all piping now. Oh, here we go. This is the auto. So we have to run the accuracy on it now. So it's going to take a second right here. For PACF. So the TS display is getting you the PACF there also. And it makes both of them, I guess. So we have, if you look at these, it might be doing better. Both of these look very similar. Here's the new one. It might beat us because it looks a little tighter. Do you see? Here's the auto. So this is the auto ARIMA right here. And here's my ARIMA that I selected. So here's the auto. And here's mine. There's small differences. Both ACFs look really clean. I should get that PACF. We're seeing something on here on lag. Ridiculous, like 17, but eh. So the doing of a combination of 1 zeros on each of the slots and the PDQs will make the model the differences. Correct. Great job right there. And the RMSC right here is 1.81, and I think that's exactly... Oh, no! The auto ARIMA beat us by 0.01, but that's within one RMSE. So our model right here, pretty similar. So overall, and then I think this is a clean right here. I think the red is showing a statistically significant ACF negative correlation, but no, because that would not be. I don't know why it's red. But that was the ACF we see right here, which is positive. Yeah, maybe those are statistically. No, because that one is. That one shouldn't be. But overall, we came very close to what the auto ARIMA found. I wish we could beat the auto ARIMA, but it's very hard since it's doing a search procedure. And yeah. So all this stuff right here is pretty interesting, Kayla, on what we're doing. And there was our model we selected, I think. And the auto ARIMA gave us a what? Let's run this one more time to take a look at what that auto ARIMA gave. And then we're going to look at some 320. Awesome work, Snag. Great job. This has been a really good talk. We're going to do sort of another contest today. I'm going to let people pick their teams. So stay tuned for class. If you show up to class, hashtag show up. There's going to be some bonus. And we're going to do a little bit of kind of model creation with what we see right here, and I'm really interested to see. We chose a our model selected. I'm going to copy paste this. Here is our ARIMA that we got, and then what ARIMA is the auto coming up with. That's what we did. So we did seasonal and regular differencing. We did an ARMA 1-1. So we did autoregressive moving average 1, both components of the seasonal and the regular. So it did a 3. Can we beat this? So it's doing a 3 right there. Man. Well, so we got everything pretty much right, or at least what the auto did. And we kind of did our own search grid. And we saw clean residuals. So good stuff right there. Now what you don't want to see, is the following. You don't want to see, and I think we have an extra parentheses, we're missing one. There we go. If you were to see, so Kayla, 100 points or ditto, you can't beat the auto. You did, oh, I did stepwise equals false. So, oh, you're right. Oh my God, Snea 100 points. Snea pointed out I did not do the stepwise procedure. I just searched the whole grid. So Snea, oh my gosh, Snea, that's 500 points right there. Great conceptual knowledge of the stepwise right there. We just searched the whole grid. But to think that we came that close to it, to think that we kind of searched around a little bit, we did our own search procedure by kind of moving around like 1 unit away from where we were at. We basically did the search procedure that Dr. Heinemann made up. But to think we came that close is great to like the full grid search, which frankly didn't take that long to do. So this right here, this model, let's go look at the time series GGTS of this, which we should be able to get. See, there's the partial, plot type partial. Is this one doesn't do it. No applicable method, observed class. So yeah, GG. TS residuals. Type equals. Can we do type equals on this? Whoo, look at that. I thought for sure you could do that. Guess not. But this right here points to data that needs differencing. This right here is ridiculous. If you were to get this right here, this goes to the first question again. This is data that needs massive amounts of differencing right here, and you see it in the ACF. So this data right here has not been differenced. Major things to do for this, so that's got a lot. Here, we'll hop back, some 320. Here we go. Good stuff right there. Let's take a look at the 320 assignment. Thank you, everyone. Good stuff right there. 201 is smooth sailing ahead. The 320 assignment right here, we're hopping down into it. And we've got the logistic. Ooh, we got the assignment due tomorrow night. Let's download the assignment right here. Markdown file ready to go. And let's take a look at this 320 assignment. The question was, I gotta go find it. On the 320 homework for 1A2. 1A2. Here we go. Is the strength of the relationship with your last amount stronger for homeowners, non-homeowners? Let's take a look at this. Here we go. Let's look at the strength of the relationship. Jumping into it. So what we're looking at right here is a regression, not a logistic regression. Reason being is last amount is quantitative. So you must look at the Y variable of interest to know, are we going to be using LM if it's quantitative or GLM if it's categorical? Now, last amount is quantitative, and we have that we're using recent average amount and the interaction between it and homeowner. And then we need data equals, and we are using the EX4 census. No. Census. Where's that census data? Is it census? Let's go find out. And we are using the EX5 donor data. That's what data we're using. So there's our model. Now let's take a look at the model here and see what we get. Taking a look at the model is going to be very important because it's going to show us the relationship. EX5, thank you so much, Anna, right there, following along. So when you visualize the model right here, what do we see? Ooh, I've got my parm flow. So I put the code over here. There it is. Yours won't look like this. Now mine will look. There we go. Okay, fixed it. So when you look at this right here, when we say stronger, what do we mean by stronger? The line would have a what or what? Like, explain to me what might be a stronger relationship right here. So the visualization, I think, can make it very clear which of these is stronger. So when we say stronger, what do you think we're looking at for these lines right here? Which line has a what or what? So if I say it's stronger, then you'd be like, oh, the line with the bigger, the what or what? Not bigger, but it's like a sledding hill. When would you say one of these is a stronger relationship right here? What would you say for, oh, that line's stronger relationship between the two variables? What would you say? Like, what would make it a stronger relationship? And a great job, 100 points right there. The steeper slope. So I think the graphic should make it pretty obvious, right? So is it no or yes? And then we'll show it mathematically right here. So is it no or yes that has the steeper slope? So the graphic can really give a lot of, like, always remember that, like, oh, I can look at the graphic. And with the graphic, I think the answer is pretty clear which one has the stronger relationship. So by looking at the graphic, which really good tips for the take home, it'd be the no. Exactly. It's clear to see that. Let's look at the summary, though, because the summary should also give us the same inclination. Now, the summary, we need to know how to read it right here and make sense of this, because we see here that recent average amount has a positive coefficient. Well, this is the coefficient of the reference line's slope. The reference level is no, so the slope for no is 0.9. Look, it's almost like going from like 0 to 50. It's almost, because it's almost a one slope. Like, that would mean, like, you know, slope goes up by 1 each time. Two individuals who differ in their recent average amount by 1 are expected to differ in their last amount by 0.97. This would be for homeowners. No. This would be for homeowners. No. For people who are not homeowners. But the big thing right here is the coefficient of the interaction. Now, the coefficient of the interaction is not that the yes line has a negative slope. It's that the yes line what's slope. The yes line's what slope is what. Like, when you see this value right here, the coefficient of the interaction means if somebody is a homeowner, their what for their slope, the slope of their line is what? Because this is an interaction on the recent average amount, which is the x quantitative variable. So that means the homeowner yes slope would be what to the homeowner no slope. So here's the homeowner no slope. I got to go this. Oh, I don't know which way. Exactly. The slope is that much less. That's what the interaction is doing right there. So this is the slope of the black line, and then the red slope line is this much less. It's not negative. A lot of people see that and they're like, oh, it has a negative slope. No, it's that much less. And you can see it behind me right here that it's a lesser slope by that much. It's not enough to make it negative. It's just, you know, this much less than the slope of the black line. Now, this would change the what of it. Looking at this component right here, homeowner yes has a what or what. Yes, Anna, thank you so much. And great work right here, Anna. This is that coefficient I just highlighted right there would change the what of the homeowner. This coefficient right here, which I think I can get them both highlighted, and I can't. There we go. That coefficient would change the what of the homeowner yes line. This coefficient here has no interaction. This changes the what of the homeowner yes line. This 2.3 means the homeowner yes line has a higher intercept by that much yes, and you can barely see it. You see this is like an intercept of 2, and then that's 2 higher. The red line has a slightly higher intercept, and that's what you're seeing mathematically here. And it's very hard to see unless I expand the graphic, but the red line has an intercept that is that much higher. That 2.3 represents that this black line has an intercept of 2, and then the red line has an intercept of 2.3 higher. So this is 2 right there, because that's the black line's intercept, the reference intercept, and then the red line has an intercept that is 2.3 higher. The red line slope is this minus this. So you could write the equation of the red line. Anna, we still got a little more time. Do you have additional questions on this assignment, things you want to talk over, like the logistic part of it? But I hope that makes more sense of what we're seeing right here. We're seeing the equation of 2 lines if you write them out. But ask any questions you have. Really good stuff right here, understanding like, okay, wait, what does that interaction do to this plot? But no, great work. Glad to hop in here and make sense of the graphic and the summary. Good stuff right there. We'll see if there's additional questions. It's the end of office hours. We did so little 201 today. Oh, you got it. Well, great work on the first question right here. And I want to say a big shout out to the Discord right now because a bunch of people are asking questions on the Discord and people are answering those questions. Sometimes I go off, do some work. Sometimes I eat some dinner and I come back and questions are answered. And I'm like, wow, people are working away. You're welcome, man. Ask those questions. Put them on the Discord. Email me. DM me on the Discord. That's it for now. We'll be back a little bit later for more office hours. I'll see everyone then. And class coming up here soon. Hey, Brian, do you know which office hours you went over at the beginning of the Project 2 in? We started Project 2 yesterday. I got the hiccups right now. N8, we got the Project 2 yesterday, and we talked about executive summary today. So check out the start of today's office hours, and yesterday's office hours are labeled. So check out yesterday's office hours where we did a lot of the assignment, and then we might have done it on Friday also. If you can't find anything, email me. And the visualization videos go over how to do a lot of it too. But N8, great work right there. 100 points. I will see everybody later. You're welcome. Bye, everybody.